Hello everybody and welcome back to IZ8 DWF repair videos. This time we have Commodore PET 4032, and this one is what is called the universal board. It is the third major revision of the Commodore PET, and it has CRT controller chip which replaces most of the discrete TTL logic that was the video interface on the previous versions of the Commodore PET. The board is arranged very differently from the other ones. Here the ROM, the major CPU, CRTC controller, 6520, 6522, all the RAM, dynamic RAM. And so let's see what we find on this board and how to repair it. Just for the record, we noticed that the interface connectors are very oxidized, so I more likely will need to retin every connector, but that would be the last step of this repair. And so let's begin. First of all, one of the problems with these universal boards and generally the Commodore PETs with CRT controller, well, not a problem actually, but for me it was because I only have the 9 inches monitors for the old 2001N that have very different sync frequencies from the 12 inches CRT that use the CRT controller integrated circuits. So I had to make an adapter to use an old monochrome display adapter which was used on IBM PC compatible, and so I made a little adapter circuit that inverts the video, well, not the video actually, the horizontal sync for sure, and this can output a composite signal and the NDA connector which is used at this moment. And the composite signal is not used at the moment. That would be useful for the 9 inches CRT that has scan frequencies compatible with NTSC or PAL, well, more or like, but in this moment it works enough with this configuration. So another option would be, if you don't have access to such a monitor that can sync to about 20 kHz horizontal sync, would be to substitute the editor ROM. I will link in the description a place where you can download some editor ROMs that can program the CRT controller to output more useful frequencies for normal PAL or NTSC monitors, and use that if you have such a universal board without the proper 12-inch monitor. So now that we can see what happens on the screen, let's begin. Okay, as you have seen on almost all other computer repairs, I always check the reset signal to the CPU, which on a 6402 is on pin 40. It should be low for 1 second or so before powering on, then goes high. And then checking the input clock on pin 37 of the 6402, and that's okay also on this board. So I just installed one of my RAM-ROM replacement board for the PET without any ROM, just to replace the whole RAM. And here's the result. So the machine seems to boot correctly and has a problem probably on the video RAM. Well, actually it's not so simple, it seems. It doesn't even do the same thing apart these vertical bars. And you see it's not, bytes tree is not correct, no cursor, some random characters appeared and the machine is stuck. So there must be something wrong. I think I will install NOP generator socket on the 6502, and that will allow me to observe the address bus cycling, because with this NOP generator the data bus is disconnected from the machine, and the 6502 always read hardwired data which corresponds to the NOP instruction. So it's just execute an infinite sequence of NOPs and generates all the addresses, and that will be useful to test the address bus on the various buffers and see if something is wrong. So far not much progress either with the NOP generator. It looks like all the addresses reaches the address buffers, which are UD13 and UD14. There is the correct output on all the address buffers. Also check the address decoders to the ROM. Where is it? Should be here. Yeah, this one. This also works. That's the correct outputs on all the lines. And I checked the addresses directly on the RAM chips, and they are good also. Okay, since I'm a bit stuck with the main problem, let's address the vertical bar on screen problem, which cannot be related to any data or address bus conflict or something. And let's see why on the schematic. So this is the video RAM, two chips each of which has 4 bits, and the other 4 bits are here on the other chip. It's called even because if we had 80 column PET, there would be another pair of RAMs that would be the odd characters, but on 4032 we only have 2. So the actual character on each position on the screen is contained in one RAM location, both these 2 RAM chips. Then the character is latched on this chip. We have latched data. Then these bits go to the character generator ROM. Not all of them, only 7 from 0 to 6. So it means we can have 128 different characters on screen. And let's see what happens then with the 7th bit. It goes on a different path, but after that he goes to this gate, and we'll see what happens in this gate later. So let's get back to the ROM. As we said, data from video RAM goes to the addresses of the character generator ROM. So if the CPU writes the wrong data on the video RAM, or the video RAM holds the wrong data because it's faulty, what happens is that the character displayed is different from what it should be. But there is no way with a faulty data bus or video RAM faulty, that we see the vertical bars on the screen, and we'll understand why briefly. Also, now notice that the lowest 3 addresses of the character generator ROM comes from another source, that is called the raw address, and we'll see what that means. But the data output from the character generator goes to a shift register, which is a device that is a parallel input and then a serial output. That means that the data coming in this chip will go out 1 bit at a time, first, second, third, and so on, output from this pin, and this forms the actual video signal and goes where we found the 7th bit from the video RAM goes also. And this is a exclusive OR gate that inverts the video signal if this other input is 1. If this input is 0, so if the 7th bit of the video RAM location is 0, the video signal goes unchanged. If this is 1, the video signal gets inverted. This configuration is called an optional inverter, in fact. So that means that if we set on a location the 7th bit as 1, the character will be inverted in the video generation circuit. So what happens is when the CRT electron beam moves from left to the right on each scan line, the shift register shifts out the bits from the data bus of the generation ROM, and each bit forms a pixel, either illuminated pixel if the bit is 1, or a blank pixel if the bit is 0. So a character is of course 8 pixel wide because of the 8-bit data bus of the ROM, and the character is also 8 rows because of the 3 row address on the ROM, as we have seen. So after a line has been scanned and pixel illuminated or not, the row address is incremented, the electron beam returns on the left, and another scan line begins with a new row address, so another row of a character is pictured on the screen. So in order to have complete illuminated column of character or the screen, what happens is that one of the bit of the ROM is always 1, or the shift register is faulty because the input is not taking the actual bit from the ROM. Yeah, sure enough, when I removed the EPROM, the ROM, I found this pin bent, which was not inserted in the socket. So that's why the vertical bar, more likely, we'll see. And in fact, that was it, the pin. The machine is booting now. I think it's not related to the main fault, but we'll see. Since it's booted and I connected a keyboard, I'll try some troubleshooting and see what happens. Okay, now it's time to address the remaining problems of this board. So I decided to burn an EEPROM for my RAM-ROM replacement dioder board with adding some diagnostics codes, and I've just enabled one ROM replacement, and the RAM is going to the mainboard RAM. and the diagnostics says A7 address bed. I don't know if you can see it. Oh well, A7 address bed. So let's try to understand what it means. Okay, since I couldn't find any problem on A7, I just decided to enable the board RAM with this jumper. Now the test looks all okay. Test the RAM, of course, the board RAM is okay, but it should write remove clip, and I don't know if it's visible on the screen because it's flashing, but it's RDL NVD PLHP. If you go on the PET ASCII chart, you will see that all the data 0 bits that should be 1 on remove clip are 0. So it seems there is a problem on data bus 0, which is not visible in this part of the RAM because probably this has been written before the problem started, and then here is evident the problem because data bit is always 0. Now I connected my current tracer because it can show me where the data 0 fault is, because it will flash with high current. And if I go on the RAM chips, the pin 2 is data, I guess it's data input, but we'll see on the schematic later. And this is data input 1, data input 2, 3, and so on. I never find any high current unless I go to data 0, which is UA19, and it starts flashing. And it starts flashing as the screen gets written. So this RAM chip is conflicting, even if it should not be enabled at all. It should do nothing on this moment. But you can see the data line is getting current spikes. So I guess UA19 has to be removed. Okay, before declaring the UA19 bad, let's check it gets indeed the select signals like all the other chips. And this is the raw address select, which is okay. And pin 4 and then pin 15 should be the column address select, and it's okay too. So let's cut pin number 2 of this chip and see what happens to the board. Okay, I just cut pin 2 and 14 of this UA19, which are the data input and output pins. And now the remove clip is correct. So let's see what happens when I substitute this RAM. So okay, I replaced the 4116 RAM, and the RAM enabled is the motherboard RAM, enabled the test image, diagnostic, and the RAM now tests good as far as this test goes, and the remove clip is displayed correctly. So also cleaned a bit the connectors. There is no need, it seems, to completely routine the connectors. They should make contact as they are. And so I will try to test the rest of the machine and see if there is something else to be addressed. It's a good thing that I will run complete test of the RAM. I have the programs on a floppy disk because all the chips are from the same batch, so if one failed, maybe someone else would be problematic. I don't know, so I would run a good RAM test for quite some time before declaring this machine good. This program tests all the 32K of RAM. It's running since a while now, and I haven't found any error, but I will leave running it for a few hours just in case there is some problem lurking around, but I don't think so. So far so good. As always, I'm trying all the ports, read and write from both tape ports. Then I will try the IEEE interface for disk, and the last one will be the user port that I will test with the CBM link program to a PC. Okay, so I connected the parallel adapter to the lab link and transferred the CBM link server, so everything went well. I will load the usual Space Invaders game after that, but the machine has passed all the usual tests without problems. So this repair ends here. I'll probably make a little explanation about how this little chip could cause all those intermittent problems, and that would be the end of this video. Okay, let's recap everything. The test result A7 address bad was not very useful. The thing that was most useful is to let the test use the daughter board RAM, which was good, and notice the problem with the data 0 conflict due to the bad 4116. Now, unlike the other previous PET revision, this particular universal board has data bus transceivers only. 8.9 is the schematic of the video RAM. So everything else, 2, 3, 4, 5 and 10, 2 and 3 is the I/O chips, 4 are the ROMs, 5 is the RAM, 10 is the CRT controller. So almost everything is directly connected to the CPU data bus without any transceiver in the middle. This is unlike the older PET revision, where the RAM at least had its own data bus transceivers. So on an older PET revision, that a fault like this was more tied to RAM access and not any access I/O, video RAM and everything, like in this case. So that the first thing that we learn with this troubleshooting is that tests cannot know everything, cannot identify any fault. So any suggestion from a test should be checked, and I really checked all the address bus lines before even running the test, and they were all fine, so I was sure the test was not correctly identifying the real problem. Actually, another thing that was misleading was the first part of the screen had all correct characters. That may be for a couple of reasons. The first could be that the RAM chip would function for a fraction of a second or a couple of seconds, and then getting warm it failed. And the other reason that could explain also why the test reported the address 7 as bad, probably because the RAM, the fault was triggered by address 7 going to 1, and the first part of the test was not testing probably address 7 as 1 until it got to the 0 page, the end of 0 page, or start of the stack test. So the first part of the screen was probably filled before the 0 page and the stack test. So the test filled the screen, the RAM was still functioning correctly, then started to test the page 0, half page 0, the A7 goes to 1, and the RAM start conflicting the bus, and so everything from this point on is starting to get bad, because the CPU cannot correctly see what happens on data on the data bus bit 0. So hope this was good troubleshooting for you, and hope you enjoyed. And thumbs up please if you like my video, and thank you for watching. See you next time.